Hello guys, today you're going to learn about diameters and chords and perpendicular bisectors. So there is a theorem that says that if you have a diameter or any segment that goes through the center of your circle and is perpendicular to a chord, then we call that a perpendicular bisector. So on this example, just looking at the image, PE is perpendicular to CD, which is a chord. So this piece right here must be the perpendicular bisector, which means it's cutting your chord down here in half, two congruent pieces. So the question says that, the question says to find PE, and they're giving us some information. They're telling us that in circle P, CD, which is a segment, a piece of a line, CD, right here, again, a segment, a piece of a line or a chord, it's perpendicular to PE, and PD is 15. They don't have PD here. They didn't draw it, but you can draw it here. That means from P to D, and of course you can automatically assume, not assume actually, it's a fact, this will be your radius. As long as it goes from the center to the circle, that is your radius. So they're giving us the radius, which is PD, and that's equals 15. And then CD, this piece right here, is 24. Find PE, and PE will be this piece of a line. So you start putting in the information that you know and what they're giving us as well. We know that PE is a perpendicular bisector, which means these two pieces must be congruent. And then PD, I'm going to put this line right here. Sometimes you have to draw it yourself. Sometimes it's there. P is 15, so I'm just filling in the blank. And then CD is 24. CD is being cut in half. The whole thing is 24. But because P is the perpendicular bisector, that means that these two pieces are equal to 12. I have a right triangle, and that right triangle is going to help me. The theorem about right triangles, the Pythagorean theorem, is going to help me find the third leg or the third piece. As long as you have two pieces of a right triangle or two sides, then you can use the Pythagorean theorem to find the third side, which is PE. So the Pythagorean theorem says that C squared is going to be A squared plus B squared. Don't forget that your C is always across your 90 degree or opposite to your 90 degree angle. So that's 15 squared equal to A squared. A doesn't matter, and B, they really don't matter. You can switch them around. Let's call this piece here A. Okay, so A squared I don't have, but I do have my B, which is 12 squared. And then 15 times 15 is 225 equal to A squared plus 144. 12 times 12. I'm going to isolate A squared. So I have A squared equal to 81. And then to get rid of the second power, don't forget I can just square root both sides, or I just erase that second power and square root 81. That does not look like an 81. Square root of 81, oopsie. A equals square root of 81, and the square root of 81 is 9. So this piece right here is 9, and I am done. Shoot me a text or an email if you have any questions, and good luck with your worksheet.